Okay, let's talk about the tubular secretion. Secretion by definition. Okay, I told you that filtration is basically from your capillary to your kidney. Filtration occurs specifically in your Bowman, in your glomerulus and Bowman capsule. Filtration should be defined as the substances going from your glomerular capillary into your glomerular capsule. So that is the filtration. And then reabsorption is like generally defined as the movement of substances from your kidney tubule back to your capillaries. That is the reabsorption or absorption. Now secretion, the definition is that it's the substances to move from your blood into the kidney tubule, tubular fluid. So secretion is very similar to filtration, but the location is different. The filtration occurs in the glomerulus and Bowman capsule. Tubular secretion, it is outside of the Bowman capsule. It occurs in the kidney tubule and also the peritubular capillaries. So all these hydrogen ions, potassium ion, creatinine, and other drugs, they will move from the blood into the tubular fluid using active transport. The urine ends up containing two things: the substance that has not been reabsorbed and substance that has been actively secreted. So these are the two things. Not reabsorbed, for example, excess water. Excess water is they are not reabsorbed. Substance that has been actively secreted. So these are the substances that has been actively secreted. So these are the three major mechanisms for producing urine. And then how do we regulate the function? What controls it? It is the water-salt balance that I told you before. In order to, by controlling the salt reabsorption or secretion, we control how much water we retain in our body, how much water we reabsorb into blood, or how much water we secrete to the urine. And by controlling the amount of water going into our body or leaving our body, we indirectly, the urinary system indirectly control the blood volume and the blood pressure of the cardiovascular system. So you can see that the urinary system assists or helps the cardiovascular system. So water and salt, NaCl present in the filter is reabsorbed. Most of them, all water and salt, they are reabsorbed in the PCT, proximal convoluted tubule. And then hypertonic, remember this term? We learned about hypertonic at the beginning of the semester. Hyper means high, tonic, high tonicity, high, you may call it high concentration of the urine. The concentration is mainly controlled by the loop of Henle. Reabsorption of water requires the reabsorption of the salt. I already told you that repeatedly. That's the major mechanism. And also you have to establish a solid gradient. The gradient of salt that will show you how you establish a gradient of salt in the loop of Henle. And then water is being reabsorbed by osmosis. But of course, osmosis, you also need a protein channel. The channel is called aquaporin. So we always said that water goes through a selectively permeable membrane by osmosis, but actually water does not go through the membrane per se. Because remember, all cell membrane, they are phospholipid bilayer. So the lipid tail inside the membrane, they will repel or reject the polar molecule, water. So water molecule, theoretically, they cannot go through the cell membrane. But fortunately, I would say most of the cell membrane, they contains this common protein channel called aquaporin. Aquaporin is a specialized protein channel that is for transportation of water. So, and we can find this aquaporin in most of the cell membrane. That's why water can do osmosis in most of the cell membrane. So, as I said, the kidney regulate the salt balance in the blood by excreting reabsorption of different ions. Most of the time is the sodium, but your kidney also regulate other ions. Majority, 99% of the sodium, they filter in the glomerulus, the filtration, glomerular filtration, the first step. And then they are returned to the blood. Approximately 67% reabsorbed by the PCT, and then 25% reabsorbed back in the ascending limb of nephron, meaning that this is the loop of Henle. So 25% by the loop of Henle, and then last but not least, 7% reabsorbed the sodium. They are reabsorbed by the DCT, distal convoluted tubule, and collecting duct. So what controls the reabsorption of the sodium? It is by the hormones, okay? Hormones like aldosterone. Aldosterone promote the excretion of the sodium ion and the reabsorption of the excretion of the potassium ions and reabsorption of the sodium ions. So what happened is that renin is a protein. I told you that it's a protein released by juxtaglomerular apparatus, which is a specialized structure in your kidney. We do not see this in. We are not going to see the picture of the location of this juxtaglomerular apparatus in this class here. But if you take anatomy, then we'll show you. And then renin, when your blood pressure is low meaning that we don't, one of the reasons is that we don't get enough blood. The blood volume drop. When blood volume drop, it can be due to dehydration, it can be due to a hemorrhage, and so on and so forth. Then we want to reabsorb more water to maintain the blood volume and also the blood pressure. Then it will secrete this aldosterone. Aldosterone is secreted by. It is not secreted from your kidney. It is secreted by your adrenal gland. Aldosterone is secreted by your adrenal gland, not by your kidneys. So your kidney secrete renin, and then renin will tell the adrenal gland to secrete aldosterone. So the aldosterone will act on kidney to reabsorb more of the sodium ion. When more sodium goes into your blood, then more water will go into your blood as well to restore the low blood pressure and low blood volume. So this is what I call the RAA pathway. It looks all these describing what we call the RAA pathway. So what happens is that when your blood pressure is low, because you may lose a lot of blood volume, drastic decrease of blood volume, then the juxtaglomerular apparatus secrete renin. Again, this juxtaglomerular apparatus is located in the kidneys. Then renin convert angiotensinogen into angiotensin 1. Angiotensin 1 becomes angiotensin 2. And then angiotensin 2 stimulate adrenal cortex. See, I told you that it is from adrenal gland to secrete aldosterone. So and then you have aldosterone promote the excretion of the potassium ion, but reabsorption of sodium ion back to the blood. Reabsorption of the sodium ion back to the blood followed by the osmosis or reabsorption of this water. Osmosis or the reabsorption of water. Last but not least, it will restore the blood volume, therefore the blood pressure will be restored, going back to the original level. This is what we call RA pathway. In the next video, I'll draw you the RA pathway so that you have a better understanding how it works.